Okay, so we are recording now.
All right.
And so if you're in Maine, let's say,
Mhm.
and you have, let's say you're going to do this. So I don't recall in the Maine that I gave you. Well, okay. Well, let's just do this.
This is for the ARM section of it.
Yeah. Yeah. So here's a string. Okay.
Mm-hmm.
And then you want to, let's say, see out
str pointer.
Yep. Yeah. So string has my strlen. Right. Yeah. You know, I better just quick refresh my memory of the project.
Do you want me to read it out at all?
No. I'll real fast go find it.
Okay.
Just want to make sure I get all the details as close as I can to help you the most. So project 1. Okay, yeah, all right, so I had it right. Okay. So we've got something like this.
Yep.
Right?
Mm-hmm.
Okay, and I know I'm forgetting about the return 0. Okay, so one of the first questions that you want to understand is how are parameters passed to a function?
Yeah.
Okay, so the first parameter, I'm not sure what type it is. We'll go over that later. No, I'm talking about in general. I'm not talking. I'm not talking about this. I'm talking about in general. So in general, the first parameter will go in some register that it ends in 0. Now,
so like X or W0?
Yes. Is it an X? Not sure. We haven't explained enough. We don't know enough. So is it an X? Is it a W? Is it a Q? That sort of thing. All right. So the second param, I'm not saying what register type it's going to go into, but I know if it's the second parameter, it's going to be some register 1. Okay, and then so on up to the 8th parameter, should it exist, is, I don't know what type it is, but I know that it's going to go into our 7. Okay. So now let's figure out what type. So we know the placement. Second parameter is going to go into X1, W1, Q1, who knows? It depends on the type of the parameter. Okay? So if the parameter is 64-bit,
it's going to use an X.
It's such as an integer or a pointer, it's going to go into an X. So if it is a 32-bit or less, it's going to go in a W. and that's an int. Okay, because, and the reason why I specify this is that it's an int or a pointer for the X is a double, a floating point double is also 64 bits. But because it's a floating point, it's not going to go in the X. It'll go in a different set of registers, which we have not explained yet. So if it is a float is also 32 bits. It's not going to go into a W register. It'll go someplace else. Okay, and we haven't explained that yet. So if it's one of the integer types, including a pointer, then the size of what's being passed will determine whether it goes into an X or a W. Okay, so are we good so far?
We're good so far. It's just me trying to think, how do I, like, for example, in the hello world, you have main and then you have store x30 sp -16. Is that like passing in a parameter or setting up a parameter, or is it something different?
No, that is something different. Okay.
That's just like making a variable.
Or no, that's not making a variable.
It's setting aside space, right?
It is setting aside space on the stack.
Yeah.
And it's pushing or placing X30 into the stack. So how about this picture? Let's move on to talk about X30. So let's first write down what happens when you do a BL command, a BL instruction. So two things happen. Let's write it down. So BL to a label, right? Like printf or puts or something, or one that you write. So that does two things. One, it computes the address of the next instruction. Okay, and it puts this in X30. Then it puts the address of the label into the PC. Let's define PC. PC means program counter. The program counter is the address of the next instruction to be executed. Okay, so let me give you a worked example. Let's say at address 1000, and that's decimal. At address 1000, we have a BL to foo. Now foo is also in memory, and foo begins at address 4000. And that means there's some instructions and finally a return. Okay.
BL is like accessing another program itself, or
no,
something?
BL is a function call. So if you wanted to, whenever you call any function, the instruction that sends you there is the BL.
So it's like saying call to main to do thing there, or
yes, somebody else is doing a BL to your main.
Yeah.
Right. You don't.
Okay.
Right.
Or you do a, like, for example, I'm typing in BL to go to sort thingy, like sort thingy, or what, something else.
Right. Okay. So where is the next instruction? They're all 4 bytes long. So at 1004, is the next instruction after the function call, right? So, and now here's the program counter. Now I know for sure that the program counter started out with 1000. Why? Because that means this instruction is being executed because it's at location 1000. So during processing of the BO instruction, it's going to calculate 4 more than 1000. So 1004 is going to go into X30. And then the PC is going to get the value 4000. Okay, so that means the next instruction to execute is going to be this one. And then another instruction executes, another instruction executes. We don't know what the code is in foo. All we know is that at the end, you're going to do an RET. So let's write down what an RET does. So the RET instruction, okay, moves X30 into the PC. So right now, what's in X30 up here? X30 is still 1004. So you execute the return. So executing the return puts X30, which is 1004. It puts 1004 in there, which means that the next address to be executed, the next instruction to be executed is the one at 1004. Okay, do you see how function calls happen?
I'm trying to understand it. But I'm going to say how I think it works, and you can correct me if I'm wrong. I probably will.
All right.
So I call foo. It's like it looks at area at line 4000 and goes, okay, X30 is going to be the answer to line 4000. Correct?
No, X30 is a 4 more than the current program counter.
So like it goes to the next thing in the program counter.
Yeah. See, look, here's how a function essentially works, right? You come down, you're doing code, and you do a function call. So you do some more code, and then you do a return. And where do you return? One instruction after you launched it into the function. Okay, that's how this works. So you're doing some code, you're executing instructions, you make a function call. The function call transfers control to the function, and some more code executes. That's part of the function. Ultimately, you do a return. And where does the return go?
It goes to step 1001 or 1004, whatever.
Yeah. And then continues. Okay?
Mm-hmm.
Now, if you had a function call within a function call within a function call,
recursion is fun.
It's actually very straightforward. So you have some code going, and you make a function call here, so that transfers control to the code inside function 1. And let's say function 1 calls function 2, and now function 2 is running. When it does a return, it's supposed to go here.
And then that goes until it hits the return, and then it goes back to the next step.
Right. And this transfer of control and the ability to come back is all performed through X30. Now there's only one X30. That's why if your function calls any other functions, it's critical that you save it on the stack, then restore it before you do the return.
Right. Which is the STR X30 -16 thing.
Right. Right. Okay. So let's talk about that now. Are we ready to move on to the STR and the LDR?
Yeah, I'm ready to move on to STR and LDR currently.
Okay. All right. So here's foo. And foo is going to call another function. So it's critical that we back up X30.
Mm-hmm.
Now here's memory. And here is where the stack pointer currently points. So when you do an STR of X30 to pre-decrement the stack pointer, okay, so that's a pre-decrement. So let's count 16 bytes. So here's 4 bytes, 4 bytes, 4 bytes, and 4 bytes. So the new value of the stack pointer is going to be here. And what's going to go onto the stack finally is the contents of X30, the current contents of X30's value. Okay. Then the code is running. When you're ready to go back, you do an LDR of X30, the stack pointer host increment. So that says the stack pointer is currently pointing here. Get the value of X30 and copy that. Get the value of X30 that it was originally, that's on the stack, and copy it back into X30, then return, takes X30 and copies it to the program counter. The stack pointer is the stack pointer at the end of the LDR instruction is then put back 16 bytes away. So this is no longer there. Okay.
And would we need to do STR X0 or X whatever whenever we need to make a new thing, or that's just superfluous? We should not be doing that.
It depends on the register. Okay. So let's say you were going to need as a local variable to stand in place of a local variable, one 64-bit value. Okay.
Or so however large a string is.
No. A string is going to go into memory. Right. So I'm talking about preserving registers. I'm still talking about preserving registers and backing them up and restoring them. You can use the STP for some register plus X30. Let's say you needed 2 more. Let's say 21 and 22. You then do an STP, X21, X22 onto the stack. That means on the way back out of the function, you have to undo this STP, then undo this STP with LDPs. And you better make sure every. Yeah.
how come it is 16 for those and not 32? Because when we're storing X30, previously it was on its own 16.
Correct, and that's a artifact of the requirement of the ARM 64-bit platform, that the stack pointer can only change in multiples of twice the length of an address. So even though in this case, we're only using 8 out of the 16 bytes, we still have to modify the stack in multiples of 16.
All right.
In this case, we're using all 16 bytes. We're using all 16 bytes, and that's fine too.
All right. And when we load it, we set it back to normal.
Exactly. Now, let's finish. Notice the order of all of these registers.
You do it in
Inverse order.
In last to first.
Yes. Okay. So the stack can also be used to store other values. Other local variables that you create yourself, you can create room on the stack for. But we haven't really looked at that yet.
Right.
But now let's get back to MyStrlen, okay?
I had a silly-ish question that I thought I might as well ask. If you were, while you're running a program, say you store X30 in one function, you do a function call, and in that other function, it loads X30, would it be blank, or would it give you the stored data from earlier?
It'll give you the address of the most 4 bytes longer than the point, 4 bytes greater than the instruction that launched you into the most recent function. Since there's only one X30, calling a function is going to overwrite X30 with each new function call. That's why the first thing that you do when you enter a function is save X30, so that you can put it back on the way out.
All right. So it's a blank space if you do a function call and have to call X30 for something.
What do you mean by blank space? I just told you it isn't.
Okay, with the way I heard it, it made it sound like it gets deleted when you call a new function. But
when you call a new function, it's overwritten, not deleted.
Right. And I was just wondering, if you have a function call within a function and you call X30, would it give you the data from the first function call if you never touch X30 in the interim?
It'll give you a value that's calculated the most recent time you executed the BL instruction.
Right. So it would not give you the value you stored it with initially.
All right, you don't store anything in X30. You let BL and RET manage X30, okay?
Okay.
All right, so it's not a general purpose register. It is in fact the link register. It establishes the trail of breadcrumbs to get you back when you return from a function. Where do you return to? That's stored in X30.
That was unclear to me. I thought X30 would be something you would utilize, not something you don't touch at all under any circumstance.
Yeah, you got plenty of other registers, so don't touch X30.
Right.
All right, except to save it and restore it. Okay. So when you call MyStrlen and give it the address of the string, what's happening is that the address of the string is being put in X0. Now I know it's an X register because it's an address, and addresses are 64 bits, and that has to be used with X registers. I know it's 0, X0 in particular, because it's the first argument. Then there is a BL to my strlen. All right, so now let's take a look at my strlen. So here's that.
Wouldn't the my strlen to the left be main and not my strlen?
Yeah, inside this is inside main, yes. This is the making of the call to my strlen.
Right.
So now here is the code for my strlen. All right, and this is going to first do the str of X30 onto the stack. Okay. The last thing it's going to do is an LDR of X30 from the stack, and then a return. Okay. Now, in between, you may need some more STRs to use as registers, as local variables. But if you look at the code you need to write, the mystrlen doesn't make any other function calls, right? So you could use just low numbered registers, because the low numbered registers do get blown away if you make a function call. If you don't make a function call, they will be preserved. You could use them, just use them. Okay. So the C code for my strlen is an int. And okay, so it's an int, my strlen, and a char star s int retval, and that's going to start out as 0. And you have while star s plus plus is not equal to 0. And all that's going to do is retval plus plus, and then a return of retval. Okay, right?
Yeah.
Okay. Now, what's in X0 right now when you get here?
It would be S.
Correct. Right. So let's use, so X0 holds S. And since we're not using any other function calls, why don't we just leave it there? All right. That means I need another register. I'll do move X1. Well, actually, I'm not going to use X1. I'll use W1, and I'll tell you why. I'm going to use W1 for the counter retval because it's declared as an int, and that's 32 bits. So I'm sorry, I'm going to, the function, my strlen is declared as an int, that's 32 bits. So when I return the number that is the answer, I want it to be 32 bits long. So I'm going to move into W1, that's 32 bits long, of a 0, WZR. Okay. So that means here, down here, I've got to move Into W0, I have to move W1 because W1 is the answer. The answer has to go back in a 0 register. Okay. Now, in between magic happens. Now, you need to write this function yourself.
That I can understand.
But let's look at how, what does this really mean? Star S plus plus not equal to 0. So
Are you looking for my response to that, or
no, that was a rhetorical question. Thanks.
okay, I wanted to be sure.
Yeah. Okay. So what does that really mean? It means, well, S is the address of a char. In other words, a byte. But what you want to do, what you want this to do is look at what S points to, compare that to 0. So you're not comparing S, you're comparing the dereferenced S.
We're comparing the contents of the address of where S is at to 0 or null.
Yes, so S is an address, and we want to look inside that address and see what its value is. So if S is in X0, which I said we might as well leave it there when we were doing this code.
So would I be writing, would I be typing out ADR X0 STR or anything, or just no? That'd be dumb.
No, you don't need to use any of those instructions because inside mystrlen, you can assume you're working on memory that someone else allocated and was kind enough to send you the precise address of. Okay, so if S is in X0, so what that means is X0 points somewhere in memory. And what you want is not the address, but what you want is the contents of that address. And if you're interested in a byte, so you would say LDRB for byte, and put that in, let's say, W. It has to be a W because it's less than 64 bits. A byte is less than 64 bits. It's just 8 bits. So it'll go into, let's say, W2. And that is, whoops, I wrote S, didn't I? Okay. So keep in mind, remember, so S is X0. Star S is X0 with brackets around it. So that is going to put, let's say this was the letter H. So this instruction is going to put the letter H into W2. So then you would compare W2 with 0. Okay, and that's this instruction there. That's this part. You'd be comparing W2 to 0. All we have left to do to completely implement this is to ensure that the last thing that happens is S gets incremented by 1, and we could do that in 2 ways. We could add 1 to x0. We could do it that way. Or, I'll erase that so you can see that it's an or. You could add 1 right here. And that's just like the LDR with a post increment of 16 at the end of functions that call other functions. So either way, when this complete instruction ends, the letter H will be in W2 and X0 will have the value 1 more than what it was a moment ago.
So we'd want to type after we do the compare LDRB W2 X0, 1, or we would do that when doing it in the first place or something else.
The LDRB happens first in order to load the next character in, and then you compare it to 0.
And because of the way you have it set up in the first place there, it'll already be incrementing itself forward again?
Yes, because I used this syntax, X0 will increment by 1 by virtue of having loaded H. Which means the next time you do it, because you're in a loop after all, the next time, if it was hello world, the next one would be the E that's loaded into W2. Okay?
Yeah.
All right. Very good. So let's keep the video on the short side. So we'll hang up now. And that way it won't be too much of a pain for other people to watch.
Yeah.
Okay.
Yep.
So do you have anything really urgent to ask me? Otherwise, I'll hang up.
I think the last question I would have is, for calling my strlen, how would I pass in S?
Okay. So in main, it's okay if you treat this. Oh, wait. In this assignment, you're getting the strings from argv, right? So
we are getting them from GitHub.
No. If you look at the code, it's while *argv, right? You're getting code. You're getting the strings that you're passing to mystrlen using argv. Okay, look at the C++ code that you start with.
I do have that. That is correct.
Okay. So very quickly, let's briefly look at what argv means. So argv arrives at main. So when you arrive at main, x1, y1, because it is the second parameter to main, y and x, it's a pointer, holds a pointer. Okay, so x1 points to memory somewhere, and argv is a char star star. And that means that what x1 is pointing to itself holds pointers. So argv sub 0 holds a pointer to someplace else in memory where it's a C string and it has the name of the program. The next entry, the next in the next 8 bytes. So this is 8 bytes wide. How do I know? Because it's a pointer. In the next 8 bytes would be a pointer to someplace else in memory where the first CMD line, command line arg is. And let's say all you have is one command line argument. That means the next 8 bytes contains 0. Now, armed with, bad pun, armed with this picture, go look at the C++ code for the while loop.
It's while argv is true.
No, it's while star argv is
pointer
true.
argv is true.
Right. So here it's true. And here it's true, but here it's false. That's how the loop ends. Okay?
Yes. What I asked is, in C++, we have a main, and then we have stuff we put in, like we're seeing, okay, we're having the list of things we're putting in. For ARM, how would I get that list? Or how would I set up the list to have things put in?
Okay. argv is set up before main executes.
Okay.
Okay, so
it's pre-stored.
You don't need to know that answer right now.
Okay.
What you can count on is that argv points to an array of pointers.
Mm-hmm.
Where the very last entry is guaranteed to be 0.
All right.
That's all you need to know. Okay,
Okay.
good. So let's hang up now so that the video is kept short.
Okay.
Okay.
I will see you tomorrow.
Good, and thanks for reaching out.
No problem.